Is there life beyond Earth? Chapter 1. The Quiet That Isn't Empty. On a winter night, I once stood on a hill so far from the city that the sky looked like a wound opening to the dark, bleeding stars. It was too cold to stay long, breath crystallized and fell like powder. But I lingered, neck aching, because that night the quiet felt crowded. Every pinprick of light carried a rumor. There are other worlds, other seas, other skies. There are other mornings. There might be other minds. Is there life beyond Earth? It is a question that keeps rewriting itself as our understanding changes. It has trailed us from fireside stories to laboratory whiteboards, from the first handprints on cave walls to spacecraft etched with gold. We know enough now to be humbled by how much we don't know. We know enough, too, to suspect that the universe is not as empty as it sounds. This book, You Hold This Voice in Your Ear, does not promise certainty. It promises a journey through what we've learned and what we're learning, a map drawn in pencil that will be smudged and redrawn. I'll try to keep our feet on the ground while we look up. I'll tell you where evidence ends and imagination begins. And I'll try to keep that imagination responsible, because the universe doesn't bend for wishful thinking. It has its own habits and measures and rules, and if we are to find life beyond Earth, we'll find it by paying attention. Number, the change in the question. There was a time when asking about life beyond Earth was essentially asking about the Moon and Mars. The local neighborhood was all we could imagine traveling. Mars, with its white caps and dust storms, seemed almost friendly. The canals that one astronomer thought he saw were the first of many mirages created not by the planet, but by our hope. Now, the question is bigger. The universe has handed us more real estate, thousands upon thousands of exoplanets, worlds circling other stars have left. Are there other planets? In the Museum of Old Anxieties, our telescopes, both in orbit and on the ground, keep building catalogs. Super-Earths, mini-Neptunes, hot Jupiters swinging close to their suns, and rocky planets in temperate zones where water might gather in lakes and pools and clouds. We're learning to taste their skies by splitting starlight, to weigh them by watching how they tug, to sketch their climates by tracking the dimming when they pass in front of their stars. Once, is there life? Was a yes or no thunderclap. Now it is a set of sub-questions, meticulous as a watchmaker's kit. Asterisk. Can planets form in the right places? Asterisk. Can water persist? Asterisk. Can chemistry grow teeth and hands and self-replication? Asterisk. Can it survive time, radiation, catastrophe? Asterisk. Does biology leave fingerprints we can see from across the dark? Asterisk. Does intelligence, if it happens, ever learn to shout, or does it mostly whisper? The old romanticism is still here. You can hear it in our metaphors, in the way we talk about Goldilocks zones and habitable worlds, but the search itself is more sober. We are building instruments that don't care what we hope. We are teaching ourselves to be patient with silence. We are also learning to recognize the sound of our own footsteps, because a lot of what we hear in the void is us. A lot of the mystery is the echo of our asking, number what counts as life. Before we look outward, let's settle on a practical sense of life, not a philosophical definition that can capture every edge case, but a working checklist. Biologists, when cornered, often offer something like this. Life uses energy and matter to maintain itself. It records information, usually in molecules like DNA or RNA. It reproduces, it evolves. It responds to the environment. It strives to keep its insides different from its outsides. In shorthand, metabolism, information, reproduction, evolution, homeostasis. That's the kid's poster on the lab wall. It works well on Earth. Elsewhere, the chemistry might be strange. The solvents unfamiliar, ammonia or methane instead of water perhaps. The membranes built of something we haven't tried in a beaker. But even then, we suspect the same logic will apply. Life needs a boundary, a way to harvest energy gradients, a machinery for copying with occasional mistakes, a scaffold for natural selection to sculpt. If not that, then something so different that we're in for the intellectual shock of our species. What we call life might be a set of strategies that matter uses to keep from sinking into equilibrium for a while. The universe wants to even its temperatures, to smooth the roughness, to run down its batteries. Life works against that local smoothing by leveraging flows of energy from star to planet, from hot to cold, from chemical disequilibrium to chemical relaxation. Life is a fiend for gradients. If this sounds abstract, think of the steam engine. The engine lives on the difference between hot and cold. If everything is the same temperature, it can't do work. Biology, too, eats difference. Plants feed on the imbalance created by sunlight. Microbes feed on the imbalance in rocks and vents. Animals feed on the imbalance that plants build in their bodies. Wherever the universe draws a line between one state and another, life imagines a ladder. And so, when we look outward, we look for ladders. We look for stars of the right stability and planets that sit where a liquid might puddle. We look for atmospheres that are out of balance in a way that suggests someone is doing the pushing. We look for rocks with the right minerals and cold worlds with liquid layers hidden under ice. We also ask a humbler question: how often does matter get to try? Because if chemistry gets enough attempts and enough time, our surprise, the jump from non-life to life, may no longer be a cliff, but a set of steps, each small enough to be inevitable somewhere. Number, the Fermi question and the human noise. Where is everybody? That's the line attributed to the physicist Enrico Fermi, posed over lunch as a kind of cosmic shrug. If the galaxy is old and big and if life is not rare, why don't we see star-spanning civilizations, or at least hear their static? Why aren't there neon signboards glowing between constellations that say hello from somewhere? The Fermi question is not despair. It's diagnostics. Either our assumptions are wrong, or our instruments are poor, or we don't yet know where to look. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but technology is a short fever that burns out. Maybe the truly long-lived civilizations learn to be quiet. Maybe they hide on purpose. Maybe the kinds of signals we hope to detect are not what they send. Maybe our own atmosphere is a loud room in which we're trying to hear a whisper. You can treat Fermi's shrug as a challenge to keep building better ears in radio dishes that look like white lilies spilled across a valley, in arrays that stitch together to make glass spread over mountain ranges, in algorithms that comb the static for patterns not born of human machinery, not the signature of an Earth satellite, or a radar, or the anxious buzz of our devices. You can treat it, too, as an invitation to look for life's quieter signatures, chemistry that refuses to relax into equilibrium, colors in an exoplanet spectrum that imply photosynthesis, cycles of gas that can't be explained by volcanoes alone. The silence is data. So is our noise. We've bathed our own planet in a shell of radio for roughly a century, 10 decades of news and music and error, and that shell is rushing outward at light speed. The leading edge of our earliest broadcast is now far beyond the oldest stars we can see with the naked eye. But the shell is thin, and it fades with distance. Even if others are listening, even if our shout has crossed their sky, the shout is soft by the time it arrives. So perhaps the better strategy is not to shout at all, but to learn to see. Number, where the evidence. First points, home. As romantic as it is to imagine hot Jupiters wrapped in storms, the first part of the answer to "Is there life beyond Earth?" hides in the nearest pockets of our own house. 3 places, in particular, have kept the lights on in our imaginations: Mars, Europa, and Enceladus. Mars, a world with memory. Mars is a room where the furniture has been moved, dried riverbeds, delta fans that look like the fingerprints of an ancient sea, minerals that only settle in water. At least once, perhaps several times, Mars was warmer and wetter. Today it's a desert under a small sky, the air too thin for water to stay liquid on the surface for long. But beneath the dust, there may be pockets where brines persist. Deeper still, the temperature rises. There might be aquifers in the rock, thin, sour, but wet. If life ever got its start there, it may have retired to these basements. Microbes slow as glaciers, metabolism turned down to a tick. Or the planet may be a fossil. No biology now, but the outline of it printed in stone. We've sent rovers to read the stones. We've taught them to scrape at clay and sniff at air and drill into bedrock. We've taught them to become geochemists, because life leaves clues, and the first clue might be that the stage was once set. What would convince us? A pattern in carbon that looks like the fingerprints of metabolism. Microfossils that are too regular to be mineral happenstance. Organics in the right place, in the right arrangements, not destroyed by the harsh ultraviolet that bathes the surface. If we find nothing, that too is an answer. It says, even with water and time, the spark did not catch here, or if it did not endure. Europa and Enceladus, oceans with roofs. Europa, a moon of Jupiter, is glass over ocean. Its ice skin is crazed with fractures like glaze on pottery. Beneath that crust, 10, 20 kilometers down, is a global sea. Tides, forced by Jupiter's gravity, need the moon's innards and keep the water from freezing solid. The same is true of Enceladus, a smaller moon of Saturn. Its south pole striped with tiger cracks that vent water vapor, ice grains, and organic molecules into space. Taste those plumes, and you taste a world. Why do these oceans matter? Because life on Earth did not need sunlit shallows alone. It exploited black smokers and white chimneys, hydrothermal vents on the seafloor where mineral-rich water erupted and met cold ocean in a turbulent marriage. There, chemical gradients are steep. There, cells can harvest energy without sunlight, turning the planet's belly heat into food. If Europa and Enceladus host vents like those, then the recipe reads familiar: rock, water, energy, time. In at least one case, the Earth, the recipe baked a cake. You would not be foolish to check the oven in the other kitchens. We don't need to postulate great whales beneath these moons. Even bacteria or archaea, in numbers too small to thicken the water, would be a revolution. The merest smear of life biomolecules rocking a balance away from equilibrium would redraw the way we think about our cosmic odds. Two independent genesis of life in the same solar system would say, this is not a fluke. This is what matter does when it gets the chance. Titan, a stranger's chemistry. While we're in Saturn's country, look at Titan. It wears a thick orange haze of organics. Lakes of methane and ethane dot its poles like spilled ink. It's too cold for water to be anything but rock. If there is life there, it would be something we do not know how to imagine easily. Something that uses methane as a solvent, membranes unlike our lipids, reactions that creep along at temperatures that make our bones crack. Titan reminds us to be careful. Habitable to us may not be the same as habitable to matter. The periodic table allows for strangeness, and evolution is a chemist that works with whatever it finds. Number, the bottlenecks and the bridges. Between non-life and life are a series of difficult steps, bottlenecks where the traffic can jam. If you want a rough, high-level sketch, first, chemistry must build complexity without a designer. Next, that complexity must start to copy itself. Then, copying must become more efficient and faithful, but still leaky enough to allow for innovation. Eventually, information must be stored and read, metabolism must be harnessed, containers must hold it all and allow traffic in and out. On Earth, we have some stories we tell ourselves about how these steps might have occurred. Life may have begun in warm ponds fed by lightning and ultraviolet light. It may have begun near vents, where minerals like iron sulfide act as catalysts for reactions. It may have begun on the surface of minerals that lined up molecules like soldiers. RNA might have been both cookbook and cook, storing instructions and catalyzing reactions before proteins took over some of the heavy lifting and DNA took over the archive. Or a melange of options may have braided together in a way we'll never fully reconstruct. Here is the point for our purposes. None of these scenarios require magic. They require time and energy and the right substrates. And even if the specific sequence of accidents that led to us is unique as individual as a fingerprint, the broad contours are not. Chemistry has its preferences. It tends toward certain shapes and cycles when it's nudged by energy and sheltered by structure. Consider chirality. On Earth, amino acids prefer one-handedness and sugars prefer the other. This might be a historical accident fixed early by chance, or it might be an inevitable consequence of the way certain reactions work. If it's the latter, then elsewhere we might find the same preferences. Some lab experiments hint that the physics of light in star-forming regions can gently bias molecules toward one hand. If so, even the prequel to biology is written in the clouds that birth stars. Consider metabolism, the cycles that cells use to process carbon and energy. Krebs cycle, glycolysis look like they could exist as geochemical cycles even without cells, whispering along in a rock's pores. If that's true, then life did not invent metabolism. It inherited it, then accelerated and regulated it. These are bridges, not guarantees. They let us say, with careful hope, that the path from mud to microbe is not a sheer cliff everywhere. In many worlds, there may be slopes. Number, the signatures we can see. Suppose life has made it somewhere. How do we, from a distance, know? There are two broad classes of clues, biosignatures and technosignatures. A asterisk biosignature asterisk is a feature, chemical, spectral, or structural that's easiest to explain by biology. On Earth, oxygen is a biosignature. It fills a fifth of our air because photosynthesis tears it from water and releases it into the sky. Oxygen is so reactive that without continuous production, it would quickly bind to rocks and disappear. Methane can be a biosignature too if its levels and seasonal cycles don't fit what volcanoes and sunlight should do alone. Find a planet whose air has both oxygen and methane in persistent amounts, and you have a planet fighting equilibrium. Add other gases like nitrous oxide, and your confidence grows. We can look for these gases by watching starlight pass through a planet's atmosphere when the planet crosses the star's face, or by watching the light from the planet itself and splitting it into its colors. The dips and spikes in that color pattern, like a fingerprint, tell us what molecules are present. It's hard work, because the signals are faint and our own atmosphere adds its own fingerprints. But it's not science fiction anymore. It's engineering. A technosignature is a clue that minds are involved. Radio signals with unnatural patterns, laser flashes, waste heat from big machines, night-side glows that might be city lights, narrow-band emissions that nature rarely makes. We're less certain about these because they depend on other species making choices loosely like ours. But we look anyway because even absence is useful information. Both biosignatures and technosignatures require a discipline you might not expect, the discipline of skepticism. On Mars, methane in the air might be from microbes, or it might be from reactions in rocks, or trapped pockets released by temperature swings. On exoplanets, oxygen might be the photodissociation of water under savage ultraviolet light, not a green world under a Sunday. Keplerian data and their cousins can be haunted by imposters, star spots that masquerade as planets, light curves that look like transits but are eclipsing binaries hidden in the glare. We check our instruments against our biases. We ask volcanologists for their models. We ask atmosphere experts to tell us how temperature, pressure, and radiation cook gases. We ask for other teams to try to reproduce our signatures with different equipment from different places. This slowness is not foot-dragging. It is a way to keep joy from making us gullible. Number. The universe's talent for extremes. If you want to believe that life can live elsewhere, first believe it can live times here asterisk. Not just in the comfortable middle ranges, but at the edges. Earth keeps surprising us with organisms that treat our idea of too much as just right. Bacteria that bathe in acid and sleep under ice, microbes that breathe iron or sulfur or perchlorate, creatures that can endure desiccation so severe that they fold their metabolism up like an umbrella and wait years for rain, algae that paint snowfields green, worms that thrive near radiation levels that would shred our DNA. There are forms that thrive at 121 degrees Celsius near hydrothermal vents, and forms that keep their chemistry running at sub-zero temperatures inside briny films. Every time we widen the circle of the possible on our own world, we widen the set of exoplanet descriptions where we can imagine life lurking. We start to ask not only whether an exoplanet has a mild Pacific, but whether it has subglacial brine that cycles with seasons, not only whether a moon is beyond its star's habitable zone, but whether tidal heating compensates and builds underwater weather, not only whether a planet's surface is scorched, but whether deep subsurface aquifers host rock-eating microbes in the dark. The point is not to pretend that anything goes. The point is that biology is not a fussy guest. It is a tinkerer. It iterates. It fills cracks. Number, the cosmic timeline. There is, however, a tempering fact. The universe is a clock with many faces. Stars age and change brightness. Planets' orbits wander. Atmospheres are built and then stolen by solar wind. Asteroid impacts reset biology's experiments like a rude hand to a chessboard. The window for life on any given world may be narrow or it may be wide. The question becomes statistical. In a galaxy of hundreds of billions of stars, how many windows open long enough for life to crawl through? And of those, how many stay open long enough for life to look back out? Intelligence, too, has its timescales. It may be a brief flare. It may learn to husband its resources and spread slow and quiet. It may turn inward, living in virtual worlds and leaving little light for us to detect. Or it may prefer the deep sustainability that avoids big, flashy energy signatures. Our own species is a teenager in cosmic time. Teenagers are loud. We don't know yet what adults sound like. This is where the question brushes hope and fear. The very tools we build to listen to other stars teach us to listen to our own. The search for life is also the search for a way to be long-lived. Every concept we refine, climate equilibrium, atmospheric chemistry, ecosystem resilience, reflects back on us. The question, is there life out there, is woven with, will there be life still times here, times if we look again in 1,000 years? Number, the human vantage. Let me confess something. Part of the thrill of this question is selfish. I want neighbors not only for what they say about the universe, but for what they might do to us. I want another mirror. We have held up the mirror of myth and art and science to ourselves and learned much. But we are still provincial. We have one example of intelligence, us. We have one example of conscience and malice and love and law. Another example would either confirm some of our guesses about what minds do with the world or dethrone them. Either outcome would mature us. And yet, there is a gentler part of me that wants the simplest possible answer to be true. That microbial life is common, that it percolates in oceans under ice, in stones warmed by tides, in mists on mountains under smaller suns. That intelligence is rare or short-sighted, that the galaxy is bright with life, but not crowded with empire. In that vision, the night is not empty, it's private. Each world learns to be a good steward and a good listener, sending little postcards that say, "We were here. We learned to share." The poet in me is content with that. The scientist in me is not content with times not knowing asterisk. The engineer in me is sketching bigger mirrors, cooler detectors, quieter receivers. We are building a new sense organ, one that lets us feel the breath of faraway seas and hear the hiss of someone else's aurora. Number, the postcard drawer. Imagine for a moment that we have a drawer labeled postcards. Each postcard is a world we've investigated well enough to have an opinion about, yes, no, or maybe. Right now, the drawer is thin. Earth is yes. Venus, brutal and shrouded, is no as far as surface life is concerned, but the story of its upper atmosphere is under review. Mars is maybe. Europa and Enceladus are maybe with a flourish. Titan is maybe, but not our kinds of maybe. Exoplanets are stacks of maybe that we are learning to sort by size, star, and soup. As our telescopes grow and our radios quiet, that drawer will fill with cards that read like telegrams. Asterisk, planet PSR, something something. Oxygen and methane both steady. No obvious volcanic explanation. Maybe, asterisk, Kepler something B. Strong sign of water vapor. Clouds. Rotation suggests ocean-land contrast. Maybe, asterisk, LHS something C, red dwarf. Flares frequent. Atmosphere likely stripped. Probably no. The drawer will not snap shut with a single triumphant, "We found them." It will fatten slowly. The answer to our question will become a distribution. Here, no, there, maybe. There again, almost certainly yes. It will be measured in percentages and error bars. It will be messy. It will be beautiful. Number, the taste of evidence. When that first strong postcard arrives, the one that most of the community agrees on, the one that wins the cautious hearts, you will think it will feel like fireworks. It won't. It will feel like a click, a notch in the right place, a quiet that is suddenly crowded with meaning. There will be press conferences, of course. There will be headlines that get it wrong and correct themselves and then get it wrong again. But if you are fortunate enough to be paying close attention, you'll feel something else. Continuity. All the experiments that failed quietly, the nights when the instrument drifted, the grant proposals turned down, the squabbles at conferences over models, those were not detours. They were the road. Perhaps the first strong postcard won't even say life. It will say disequilibrium consistent with biological activity. It will say abiotic explanations appear insufficient under present models. It will say further observation required. If you're not used to scientific speech, you'll want to shake the authors and make them shout. Be patient. This is how grown-ups talk when they're trying to be sure. This is how we keep from fooling ourselves, which is so easy to do. And after the click, there will be the work of kinship. What kind of life? How robust? How deep in time? Is it an ecosystem or a lone metabolism? How does it handle stress? Does it make pigments and build shells? Does it have predators and prey? Or is it a bacterial democracy with gossip and molecules? We will learn to talk about alien ecology with the same casual specificity with which we talk about weather. There's a planet around this orange dwarf where the seasonal methane bloom in the stratosphere is late this year. The vents must be clogged. We'll develop a folklore. We'll name features after our poets and their poets. We'll argue about the ethics of sending a probe through a sky that might be alive in order to taste it, and then we will face the hardest choice, whether to let our machines wait at the edge of a lake and watch quietly, or whether, as a species, we will press our hand to the glass. Number, the edge of the glass. I like to imagine that future scene with a sense of proportion. We won't be Prometheus stealing fire. We'll be something smaller and, in its way, nobler, patient visitors. We will spend years rehearsing. We will sterilize and sterilize again. We will design a lander that doesn't leak our microbes. We will test it in deserts, under ice, in the deep ocean, in caves. We will argue ourselves into caution. Maybe we'll send swimmers into Europa's sea, little autonomous fish that can carry a lab in their bellies and sing back to a relay under the ice. Maybe we'll hover above Enceladus and sip its plumes with instruments finer than any tongue. If we find life there, we will have to learn to love not touching. This will be a shock to a species that touched everything it could reach. But we will have learned enough by then to be careful. we would have grown. And if we find nothing, if Mars is a fossil, if Europa is sterile, if Enceladus is a cold, pretty chemistry set, then we still have the exoplanets, which by then we will read with the same intimacy with which we once read sea charts. We will not be defeated. We will have placed our bet more widely, and the universe is large enough to pay out to patience. Number, the quiet crowd. Let me take you back to that winter night with the powder air. I thought I was alone, but I wasn't. Even if there is no other mind in the galaxy, and I doubt that space itself is crowded with the conditions that once made us, crowded with the ways matter has learned to organize, to repeat, to repair, to mistake, and then improve. The very atoms in our bones were built in stars and scattered by violence into clouds that cooled and condensed and spun and lit again. We are already the product of 1,000 acts of sharing. The quiet is not empty, and so the question, is there life beyond Earth, is partly about company and partly about gratitude. The search sharpens both. It makes us ask what we would say if we could send a postcard back in time to the first microbe that took a risky chemical step. It worked? Keep going. There will be cities and poems. There will be instruments that listen to the breath of faraway seas. The first chapter of this book cannot answer the question. It can only make it worth your time. I hope it has. In the next, we will walk through the instruments and missions that bring the question down from myth to measurement. Why certain telescopes matter, how we might sample an exoplanet's air from across light years, what a responsible first contact with a microbe under ice looks like, and what it would mean, in practice, to share a galaxy. For now, hold the simple picture. A dark sky, a crowded quiet, and a species that learned to listen. Chapter 2. Instruments for a crowded quiet. The first time a telescope made me cry, it wasn't the image that did it. It was the sound, a soft hum, and a clicking relay as the dome rotated and the slit opened to the night. I felt a draft against my skin and knew that the sky was now part of the room. We were drawing in starlight, photons that had wandered for centuries or millennia to crash at last into a detector chilled almost to absolute zero. It felt like meeting a traveler on the road and offering them water. Tell me where you've come from, you want to say. Tell me what you've seen. That's what the second half of this journey is about. How we invite the sky inside and how we listen to what it says. It's about turning a poetic question into a program of work and then into an answer you can live with. It's about the engineering that makes awe reproducible. If Chapter 1 was a night walk, Chapter 2 is a laboratory morning. Coffee rings on the bench, a graph on a screen, the small, precise joy of a baseline established. We will build, in these pages, a ladder, from the simplest hints of life to the first confident postcard, from the postcard to a census, and from the census to the kind of humility that lasts. Along the way, we'll try to keep our feet on the mat of what is possible while peeking at what is almost possible. Every breakthrough began as almost. Number the eyes that taste air. When you look at a distant planet, you don't see the planet. You see what it does to light. In the most forgiving cases, when a planet passes in front of its star, some starlight sifts through the planet's atmosphere before it reaches us. The atmosphere steals certain colors, depending on what molecules are present, and the star's spectrum arrives with tiny bites missing. The missing bites spell out a chemistry. This is *** transit spectroscopy. ***. a phrase that sounds like bureaucracy but is, in fact, alchemy with error bars. Imagine laying a rainbow on a table and running a finger along it. Somewhere in the orange, the rainbow dips, sodium. In the blue, it wiggles, water vapor. Farther in the infrared, there's the strong, toothy signature of carbon dioxide. Somewhere else, methane. And if, in the right temperature regime, in the right amounts, you saw oxygen and methane together steadily, season after season, you would have a reason to stand very still. But transit spectroscopy doesn't always cooperate. Not all planets transit from our vantage. Not all stars are kind. Not all atmospheres are clear. Some planets are wrapped in haze that paints their spectra with flatness, as if the sky were holding its breath. For those, and for many others, we turn to other tricks. Direct imaging with coronagraphs and star shades that blot out the blinding parent star. Phase curves that track how a planet brightens and dims as it shows us different faces. Asterisk, asterisk, emission spectroscopy. Asterisk, asterisk, catching the faint warmth of a world itself. All these methods eat signal to noise for breakfast. To feed them, we build instruments that are less like cameras and more like ritual, cooling optics to cryogenic temperatures, so thermal noise falls quiet, polishing mirrors until the surface deviations are measured in atoms, unfolding observatories in orbit like origami that remembers the shape of silence, teaching detectors how to listen through a storm of cosmic rays and electronic gremlins. Even with all that, spectra are confessions spoken through a wall. We learn to calibrate away our own atmosphere, to subtract the stars' tantrums, to model what clouds do to light. We compare to volcanic worlds, to dead rocks, to photochemical soups. And slowly, we begin to be able to say, this planet breathes. Number, what counts as a breath? We've talked about biosignatures. Now let's dress them in protocols. To claim life from afar, we'll need a asterisk, asterisk chain of sufficiency, asterisk, asterisk, not a single spectacular line on a plot, but a braid of evidence that resists easy alternative explanations. The braid might look like this. 1. Asterisk, asterisk, context, asterisk, asterisk. A planet of the right size and likely composition, in the gentle band where surface liquids are plausible, orbiting a star that is not too tantrum-prone. Its mass and radius suggest rock, not fluff. Its density suggests a core and a mantle, not a balloon. 2. Asterisk, asterisk, climate asterisk, asterisk, indications of a stable, long-lived atmosphere. Phase curves that hint at ocean-land contrast, or at least at a circulation pattern that doesn't cook one hemisphere while freezing the other. A greenhouse effect that is neither runaway nor non-existent. 3. Asterisk, asterisk, chemistry, asterisk, asterisk, co-presence of gases that should destroy each other unless they are being replenished. Oxygen and methane are the headline duo, but other combinations matter. Nitrogen oxides with the wrong ratios, phosphine in contexts where volcanism and lightning can't explain it, dimethyl sulfide or isoprene in quantities that argue for embarrassment if geology tries to take the credit. 4. Asterisk, asterisk, temporal behavior, asterisk, asterisk. Seasonal variations that make sense as ecology blooms and declines that track a year, not simply as temperature swings in a sterile sky. lags that match the thermal inertia of oceans, day-night asymmetries that suggest a biosphere following light. 5. Asterisk, asterisk. Multiplicity of probes, asterisk, asterisk. Independent instruments and methodologies. Transit spectra and direct imaging agree. Ground and space telescopes converge. Observations, separated by years, still point to the same disequilibrium. 6. Asterisk, asterisk. Abiotic exhaustion. Asterisk, asterisk. A careful reckoning of all non-biological pathways. Photochemistry, under the star's spectrum. Outgassing models that include every feasible volcano. Lightning yields, impact chemistry. If, after all that, there's leftover signal, then the word life may enter the paper cautiously, with the dignity of a guest finally invited to sit. This is not moving the goalposts. This is refusing to score a goal on ourselves. It's a discipline learned from a century of almost miracles that turned out to be fog on the lens. When we finally call it, the call will stick. Number. The ears that hunt for minds. While the eyes taste air, the ears hunt for minds. It is tempting to imagine that if intelligence exists, it will shout like we do. Radio and microwave beacons, broadband chatter, carriers modulated with math, and so we search the radio sky, because radio is a sweet spot in the spectrum. It travels far, cuts through dust, and is relatively cheap to produce. We sweep the sky with dishes that listen to frequencies where the universe itself is quiet, the so-called water hole, between the hydrogen line and the hydroxyl line, hoping that someone else had the same idea. But we've grown less naive about the forms intelligence might take. Radio is just one kind of technosignature. Others may be optical. Picosecond laser pulses in narrow bands that nature rarely emits. Others may be thermal. Waste heat from computation or industry spilling in mid-infrared tails too smooth for volcanoes. Others may be subtle. The spectral fingerprint of pollutants, CFC-like molecules that no volcano knows how to make, hovering in the air of an exoplanet like a decades-late confession. Others may be geometric. Unnatural night-side patterns, the quiet geometry of cities winking at us in the glow of reflected starlight. There is humility knitted into this hunt, too. We don't know what long-lived intelligence optimizes for. Perhaps it learns to be so efficient that its waste heat is lower than background. Perhaps it migrates to the cold to minimize thermodynamic costs, and its signals ride frequencies we barely consider. Perhaps it prefers the deep time of orbit around small stars, or the inside of data architectures that have no sky. So we hedge. We build searches across modality, and we automate them. We teach machine learning to find needles in haystacks while flagging any needle that looks suspiciously like a bent paperclip, our own interference. We populate the null results with meaning and publish them with care. We looked here, this hard, for this long, and found nothing above this threshold is not a failure report. It's a chart, showing us where not to wander again. If this sounds like a long obedience, it is. But the ears, like the eyes, get better with practice. The dynamic range increases. The excuses for not looking too expensive, too speculative, melt in the heat of engineering progress. We listen because listening changes the listener. Number, microbes in the basement. Let's descend from spectra and signals to something messier and nearer. The work of catching a microbe in the act. The sub-ice oceans of the outer moons, the brines under Martian regolith, the acidic clouds above a brutal planet. Our first encounter with life that has no words. There's a reason astrobiologists rehearse in Antarctica, in the Atacama Desert, in the dry valleys, and the subglacial lakes. Those are Earth's ports of entry to other worlds. Clean rooms smeared across landscapes. You learn what contamination means when a single human sneeze can be mistaken for an ecosystem. You learn to read isotopes with a prosecutor's patience. You learn that life leaves layered signatures, the shape of a cell, the distribution of carbon isotopes, the presence of lipids, the ratios of certain elements, textures in rock, that cells in chemistry create together. Our first responsible touch under alien ice will be an exercise in asceticism. A **crybot*** melts a path through tens of kilometers of ice, a sterile spear tip of hot water that recycles itself closed, never letting our microbes ride the plume downward. A **hydrobot*** slips into the ocean carrying microscopes, mass spectrometers, microfluidic labs on chips. It pulls in a sip, and in that sip there may be nothing, or a geochemical poem, or the quiet throb of metabolism. What then? We will not say hello. We will say isotopic fractionation. We will say lipid membranes of unfamiliar composition. We will say metabolic pathways that make sense of the vent chemistry. And beneath the jargon will be the shape of an answer. The universe tried to live here, and it worked. It may be that the first news will be negative, sterile waters, sterile rocks. If so, we will not have wasted our time. We will have spared those oceans our ignorance and learned to be careful with worlds that cannot consent. We will have made our machines into monks, disciplined, silent, present. Number, the senses. Suppose we get lucky, by which I mean we are patient and careful and honest. Over years, the postcard drawer at the observatory fills. We have a dozen strong maybe yeses, a handful of almost sures, and one or two consensus yes targets that have been observed by every instrument we can throw at them. What does it mean to that there is life beyond Earth? It means we stop asking yes or no and start asking what kind of and how much. We build a **census***. Maybe we find that red dwarf worlds, once feared for their violent flares, often host thick-aired planets with photochemical shields and deep oceans that buffer the tantrums. Maybe we find that sun-like stars are less fertile nurseries than we flattered ourselves to believe. Maybe sub-Neptunes with hydrogen-rich envelopes have slow, weird biochemistries that scavengers of gravity couldn't have predicted. Maybe life under ice is the rule, surface life the exception, and the galaxy's biomes are caves and seas with no sky. Censuses are not thrilling in the way announcements are. They are the tools with which civilizations write curriculum. With a census, universities change their intro courses. With a census, high school posters get updated. With a census, poems pick up new metaphors. There will be a decade in which you overhear at a bus stop a conversation about the seasonal methane bloom of a world with a name like a password, and you'll realize that the weird has become local. The census will also give us our first good estimates of something we've only gestured at with equations. The *** frequency ** of life. If two origins of life exist in one solar system, say, us and a European cousin, that frequency is high enough to make the galaxy feel crowded. If, despite oceans and time, the outer moons are sterile, but exoplanet atmospheres sing with disequilibrium, then we learn that sunlight plus continents may be a key we didn't know mattered. If both local and distant searches find only chemistry, then we have learned something profound too, that we may be rarer than we'd hoped, and therefore more obligated to be careful with ourselves. There is a grim version of that last lesson, a lonely one. There is also a luminous version, rarity as a summons to stewardship. If the universe doesn't make minds often, then every mind is a sanctuary. Number, ethics under new skies. The first strong postcard will do more than nudge telescope time allocations. It will force us to grow up. Planetary protection will stop sounding like fussy paperwork and start sounding like manners. The prime directive of fiction will harden into protocols. No landed missions on confirmed biospheres without a global consensus. No biocides. No biological sampling without return to orbit, quarantine, and sterilization beyond the reach of any accident. No terraforming of anything alive, no matter how simple, because the right to become is not ours to steal. We will argue. Some will say that microbes do not have rights. Others will point out that we were microbes once, and that rights are not magic tokens bestowed by complexity, but choices made by the strong to protect the weak. Some will say, we cannot know a thing we have not touched. Others will say that we can, if we are clever, learn to be patient, remote sensing, long-term observation, in situ chemical analysis with robot monks we trust. There will be proposals to bring samples home. There will be wiser proposals to build laboratories in orbit and to keep the door between worlds closed. We will need not just rules, but stories, narratives that give rules weight. We will tell our children about the time we decided times not times to touch a sea, and the good that came of that refusal. We will coin phrases like the covenant of the ice, and mean them. We will design rituals for mission briefings that are half checklists and half vows. Ethics always grows sideways from knowledge. The universe has kept us in a playpen for a long time. The gate is open now. We can leave without breaking the fence. Number, the first conversation. What about intelligence? What about that dream of minds meeting across the dark? It may happen quietly. No sudden burst of prime numbers, no wow signal that swings opinion in a weekend. Instead, a small anomaly in a survey becomes a narrow-band coherent tone after stacking months of data. Its Doppler drift matches a planet's rotation. Its frequency is near a universal line, a place where any physicist anywhere would look. It is faint. It is constant. It is indifferent to us. We point many ears at once. We observe through the star's day, through its year. The tone jitters a little, then steadies. Then perhaps this is projection modulates as if it had a heartbeat. The papers are careful. The news is not. The towns have a week of strange silence and stranger music, and then, maybe years later, a pulse, a pause long enough to measure. Then another pulse, a code, or a machine's clock, or a lighthouse turning. Human beings do what we always do. We argue over interpretations. We project. We parody. We write novels. We postulate motives for shadows. the deeper work continues. Statistics and signal processing, replication, null tests, other teams with other dishes. If the signal persists, if everything human falls away under the pressure of repetition, we will have our second answer. Intelligence not ours, indifferent to us, busy with whatever business long-lived minds conduct. We will not know what it means. We will only know that somewhere chemistry learned not just to copy but to imagine. What do we say back? Perhaps nothing. Perhaps the first wisdom we learn is that we are not ready to announce ourselves. Perhaps we coordinate a reply that is modest and simple. A map of our local stars, a chemistry table, a hello written in the constants of physics. Perhaps we decide that listening is an action, not a pause, and that listening longer is the correct first move. In the old stories, contact changes everything in a day. The taxes, the borders, the feuds, the market, the dust under the bed, they remain the next morning. But something does change. The axis of our metaphors, the we in our conversations, gets a new horizon. Cynicism loses a little of its glamour. The old question, are we alone? Steps aside for a bigger one, what are we like? Knowing that we are not number, the answer, stated plainly. You've been patient. The book promised an answer, and here it is, stated as plainly as the universe will allow. Asterisk. Yes. Asterisk. There is life beyond Earth. The answer is asterisk, yes, asterisk. Not because we wish it, but because the balance of evidence will tip there. It may tip first in the form of a strong, reproducible atmospheric disequilibrium on a rocky exoplanet that refuses geologic explanation. It may tip in a hydrothermal plume beneath ice that carries lipids nobody taught to arrange, and membranes that manage the commerce of ions with the fussy neatness of cells. It may tip in a radio tone that declines to be natural for years on end. However it tips, it will not be a single sensational line on a plot that rips through the news cycle and fades. It will be a scaffold erected with many hands, revised as instruments improve, argued over until the argument collapses under the weight of the same result from too many directions. If the universe is as generous as I think it is, we will add a second sentence not long after, asterisk. Life is common, asterisk. Maybe not intelligence, maybe not industry, maybe not story, but metabolism, membranes, messiness, mutualism. The quiet that isn't empty will stop pretending. And if the universe answers more austerely, if the postcard drawer fattens with no and only a sliver of maybe, then the first sentence still stands. We are one instance. One is greater than zero by an infinity of meaning. Number. The work of gratitude. After the press conferences, the T-shirts, the think pieces, the votes, the petitions, the policy, the inevitable bad movie, and the better poem, it will be quiet again. The telescopes will open to the night. The thermal straps will creak. Somewhere, a graduate student will hold a mug too long and forget to drink. Somewhere, a janitor will sweep glitter and not roll their eyes. Somewhere, a child will wake at 3 a.m., go to a window, and see nothing with their eyes, but feel something with the part of the mind that learns from old fires. What then? We keep doing the work. We write new instrument proposals. We teach the next cohort how to be skeptical and how not to let skepticism fossilize into smugness. We update our ethics and add teeth. We practice contact by practicing empathy with each other. We reroute budgets. We build starshades and cryobots. We learn to share telescope time like bread. Most of all, we keep the answer from shrinking. It is not a trophy to mount on a wall. It's a metronome that ticks under everything else we do. It runs under climate work, under public health, under the building of cities, under the rule of law. It says, you live in a world where others can live. You live in a universe that gives second chances. You are not the only way matter has learned to tell stories. Number, the last walk. Let's end where we began, outside under a sky that baffles and invites. It is no longer winter now. It is summer, and warm air carries the ghost of grass. The city is far, but the light still kisses the horizon. The Milky Way is a smear of salt. Somewhere up there are the worlds we've tasted and the seas we've spared, the sounds we've parsed and the tones we've resisted the urge to answer recklessly. Somewhere up there are cousins, microbial or mindful, who do not know our names. The question that started this book, is there life beyond Earth, has done its work. It pulled us through instruments and ethics, through patience and the glamour of not knowing. We don't need to repeat it. Instead, hold this. We are part of a pattern that repeats. We are not the first place the universe has tried. We will not be the last. The darkness is not a void. It is a medium, like water, and life is what swims. Walk home with that. Let it change how you step, how you speak to your neighbors, how you vote, what you build, what you refuse. Let it change what you think a victory is. Let it be a good weight. The night will still be the night, cicadas soft as static, the breath of the hills slow and old, but your listening will be new. And if someday, somewhere, someone reads this not as a human but as another kind of listener, I hope we have left you a clean shore to arrive at. I hope our postcards seemed careful, and our instruments sounded like patience, and our stories tasted of gratitude. I hope you will forgive our noise and hear, through it, the note we tried to hold. Hello, we are here. We learn to share.